Hello everyone, today we're going to talk about what VLAN is and how VLANs communicate with each other. Before discussing VLAN, let me ask you all, do you know what a VLAN is? VLAN actually stands for Virtual Local Area Network. So, if we talk about Virtual Local Area Networks, what is a local area network, or LAN? In this context, it refers to the data on the same network segment that is forwarded through a switch. This is what we call a local area network. If in this scenario, we connect two computers through a switch, these two computers will forward data on the same network segment. For example, if PC1 accesses PC2, that constitutes a local area network. Now, if we add another switch and connect two more computers underneath it at this point in the process, how many local area networks is this? Without connecting the two switches, this is actually still one LAN. However, if in the future we connect the two devices together, for example, by connecting one switch to another switch, at this point we actually have one LAN, meaning I can connect more switches through a switch to form a larger LAN. But if we say that the LAN is getting bigger and bigger, is this a good thing? Let's see. If we look at the devices we usually encounter in projects. In this process, it's not like the neat and square shape we see now. Its actual appearance is like this, with many interfaces on it. The interfaces we usually see in projects are generally 24 or 48 ports. If I keep connecting more and more switches in this process, it's actually not a good thing. Why do we first encounter the issue of a broadcast storm? What is a broadcast storm? It means that if my device sends out a broadcast, the switch will perform an action upon receiving it. This action is called flooding, which means it replicates and sends a copy from all its remaining interfaces. Now, in this scenario, switch 2 will also flood upon receiving it, meaning that any device in the network can actually receive it. But what if every device does this? If my device also sends a broadcast, the switch will flood it as well, sending a copy from all remaining interfaces. If I have more devices and each one sends a broadcast, will this have a significant impact on our computers? Actually, I want to tell everyone that it won't have a significant impact, because the performance of our computers today is different from decades ago. So, sometimes when you read some copy online or articles or watch some videos, they might tell you that it will greatly affect our computers. In reality, it won't affect our computers. Nowadays, gigabit is the starting point, whereas in the past, when we bought computers, for example, the network cards were 10 megabits or 100 megabits. So there is actually a big difference in performance. Besides this, are we saying there are no other hidden risks? That's not the case either. There are viruses involved here. What kind of viruses? I don't know if you've heard of it, but a couple of years ago there was actually a virus called Eternal Blue. This means that when your computer is infected with a virus, whether it's from clicking on some phishing software, phishing emails, or some malicious plugins, if your computer is infected with a virus, all the files and data on your computer will be encrypted. And it doesn't just affect your computer, it can also affect others' computers. Here it spreads the virus in a broadcast manner. So as long as you are on the same local area network, and your computer has no protection, it will be infected once it receives it. In this scenario, if we have 1,000 computers on the same local area network, even if just one computer gets infected with a virus, the remaining 9999 are doomed. So how do we solve this with VLAN? On one hand, we need to address the virus itself, and on the other hand, we can segment this large local area network, isolate it, and divide it into multiple smaller local networks. For example, in this process, we generally divide according to interfaces in projects. What does this mean? Here, if I want to segment it, for instance, originally with 1,000 computers, if one computer gets a virus, the remaining 999 get infected. Now I can divide it into two VLANs. In this VLAN, there are 500 computers, and in that VLAN, there are 500 computers. If one computer gets a virus, it can only infect 499 computers, preventing all devices from being infected. So, how is it managed? How do I manage between different VLANs? In this context, it's actually about categorizing through a tag label. For example, if it comes from the future, I label it with 10. And if it comes from this side, I label it with 20. Different micro quantities cannot communicate directly. We must use the same micro quantity to communicate. Now, in this process, how do we configure it? Let's take a look. First, we divide it into 3 steps. The first step is to create a micro quantity. In the future, when we enter the device, it will initially open in this user view. If we want to configure it, we need to enter the system view through the system wave and configure the microLAN here. For example, microLAN 10 and microLAN 20. We create two microLANs here. Suppose the place I'm in is a hospital. Now here, this is the switch on the first floor, and this is the switch on the second floor. On the first floor, we often handle registrations, and on the second floor, we have consultation rooms. Suppose here, this is our registration department, and it is microLAN 10, and in the future, it will be microLAN 10. If it's our security, it is microLAN 20. Now, if this is a consultation room, in the future, then who should I communicate with? Shouldn't I be communicating with PC1? I can't just say I registered on the first floor and then went to the second floor without any record. That's not acceptable. We must communicate with each other. So in fact, this device on my right is 20. And in the future, we can create 10 and 20 within this device. Now, if I don't create it, is there a microLAN inside? Actually, there is. By default, all interfaces are in VLAN 1, even if we don't create anything. Now, in this context, we are just creating a single VLAN. Creating VLAN 10 and VLAN 20 solves the issue. What if we want to create multiple VLANs at once? For example, right here. My department is divided into VLAN 1, VLAN 2, VLAN 3, all the way up to VLAN 100. This way I can VLAN batch. From 1 to 100, I can simultaneously create 100 VLANs here. What if they are multiple non-continuous ones? For example, if I want to create VLAN 10 and 20, I just add a space in between. Then, by pressing Enter, I configure both with one command. After configuring the VLAN, we say this is just the first step. We configure the VLAN through VLAN 10 or VLAN. Creating VLAN 20 is creating a single one. If you want to create multiple, it's VLAN batch 1, 2, 100, which are multiple continuous ones. If they are non-continuous, it's VLAN batch here. 10, 20, which are non-continuous. After creating the VLAN, we need to modify the interface type. The interface types are divided into three categories: access, trunk, and hybrid. Among these, if our device is powered on, it defaults to the hybrid mode. However, generally we choose to use access or trunk because these two are universal, meaning they are supported by any manufacturer. If you use hybrid to connect with another manufacturer's equipment in the future, it might lead to communication failure. Now, during this process, we change the type of the interface, especially if I plan to connect some terminal devices, such as computers in the future. For example, printers, servers, or cameras. At this point, we need to use access. We need to enter the interface J001, to modify the interface type, port, link type. And here, we change it to access. This is responsible for tagging the data when I receive it. If I send it in the future, I will remove the tag for you. During this process, whether it's sending or receiving, it's actually an operation executed by our switch interface as it enters or exits the switch. Overall, it will not affect our users, because no one wants to think about, oh, I need to go online every day, what VLAN I belong to, or which VLANs I can communicate with. These are not our main concerns. So who considers these? It's the network administrator's responsibility. Now here, we need to plan for it. When receiving, I need to tag it with a VLAN ID to identify which VLAN it belongs to. When sending, since our computer is a layer 3 interface and can configure IP, it cannot recognize VLANs. So I need to strip off this tag, which is something that access can do. Next, I need to assign it to a VLAN called port default VLAN, which means that in the future, if I receive something without a tag, I will assign it a VLAN ID of 10. Alright, now within this context, I need to assign the number 1 interface. And for the number 12 interface, I also need to assign it. I will assign it to VLAN 20. The configuration is the same. Change the interface J002 port link from tap to trunk access mode. After making the changes, what do we do? During this process, we map the port default VLAN to the corresponding VLAN. Here we want to set it to 20, so we input 20. This is our first and second step. Above, we also need to configure it. During this process, for interface J001, set the port, link type to access. Here, the port default VLAN is 10. And for our second interface, interface J002, set the port link type to access port and the port default VLAN to 20. After configuring everything here, What do we do in the future? Here, PC1 and PC2 are on different VLANs. When I receive the packet here and send it out, I notice, hey, I'm on VLAN 10 and you're on VLAN 20. Can we still communicate with each other? No, we can't. For example, let's look at this scenario. In the future, if PC1's IP address is 192.168.1.10 and PC2's IP address is 192.168.1.11. Originally, within the same network segment, we could communicate directly. Now, let's look at 192.168.1.10. 255.255.255.0. This is its subnet mask. Here, click apply, and for the second one, it's the same. 192.1168.1.11. 255.255.255.0. During this process, for the 192.168.2 gateway, we can configure it in advance here, or we can choose not to configure it. Now, with just PC1 and PC2 here, can they ping each other? The result should be that they cannot because they are not on the same VLAN. Why? Now, between 1 and 2, they cannot ping each other. What about between 3 and 4? One is on VLAN 11, and the other is on VLAN 20, so they also cannot communicate. We need to configure them as well. 192.116.8.2, 1.12, and 192.168.1.13. During this process, 1.43, 192.168.1.12 is PC3's 255.255.255.0 subnet mask. For PC4, here it is 192.168.1. In this process, it is 1.13. We configure its subnet mask as 255.255.255.0. Now, during this process, let's look at PC2 accessing PC1 and PC3 accessing PC4 at 192.168.1.13. Can they communicate at this time? Can they? The answer is no, because they are not on the same VLAN, so they cannot communicate during this process. Now, if my PC1 and PC3 are on the same VLAN, can they communicate? At this time, let's consider and take a look at 192.168.1.12. Can they? Alas, they still cannot. What situation causes this? It's because here, I will tag it with VLAN 10, and from this interface, we want to send it out to PC3. But did we configure this interface here? No, the unconfigured interface by default is in VLAN 1. All interfaces by default are in VLAN 1 unless changed. You are VLAN 10, I am VLAN 1, so I won't let you pass. But at this point, can I configure this interface as access? Can I? No, because access can only serve one VLAN. Either it's VLAN 10 and 10 can communicate with 10, or it's VLAN 20 and 20 can communicate with 20. But VLAN 10 and VLAN 20 cannot use the same path simultaneously. So what should we do? We use a trunk port, which allows me to retain multiple VLANs and communicate through this link. Here, I can utilize a feature called an allowed list. This means that when someone comes over, I can allow them through, enabling both VLAN 10 and VLAN 20 to pass. Here, we retain the tags, so when they reach the second floor switch, it knows where you originally came from and whom you want to access. Overall, this process is quite clear to us. Now, here we configure the interface J003 on SW1. The overall command for port link tap is the same. But here it becomes a trunk. During this process, the port trunk allows VLAN 10 and VLAN 20 to pass through. After allowing them through, it's the same on our second switch. Here, we enter interface J003. Port. Link bar type. Trunk. Port. Serial port. Along the path. NLAN or... Now here we can also communicate. Well, so now if I can communicate, may I ask here to look at 1 and 3 again. Is it possible now? Because here I tagged it with 10 and kept the tag here. I carried the 10 over and kept it here as well. So when I send it out from this access interface, from my interface, we strip off the 10 tag, allowing me to communicate normally. So now, who can 2 communicate with? It can only communicate with PC4 within the same VLAN. Let's configure it. Configure 192.168.1.13. At this point, only the same VLAN can communicate. Different VLANs cannot. But are we saying that our current network setup is correct? Is it correct? Should I connect it this way? If in the future my switch, as my hospital develops better and better, I have a first floor, second floor, third floor, and fourth floor. For example, within this, the first floor, second floor, third floor, and fourth floor all go online through the fourth floor. One goes online through 234, 2 through 3 times, and 3 through 4. Is this okay? In fact, this network setup is not good. Why? Because if there is a problem with the third floor, then the equipment on the first and second floors cannot access the internet. Therefore, when we set up networks in enterprises, we usually connect terminal devices like computers, printers, servers, and cameras to what we call our access switches. These access switches are often connected to aggregation switches. If it's a company that cares a lot about network reliability or in a network environment, it often deploys 2 aggregation switches, connecting the access switches to each of them. Just like in this setup, if one side is disconnected, I can still access the internet through the other side. So in this context, we say we will use this to create a sense of reliability. Now, during this process, we are waiting for this device to boot up. Once this device is powered on, can PC1 still ping PC3? I have now added a new device, but I haven't configured it at all. So at this point, it won't work because I tagged it with 10 here, and it's reserved here. However, this interface should have been reserved. But since I haven't configured it, it defaults to VLAN 1, and I can't allow traffic through. So, during this process, I can't establish communication. See, what should we do? In this process, we need to change the switch model of this device. Specifically, the interfaces of this switch, to trunk interfaces and allow the corresponding VLANs. Now let's configure it here. First, in this process, we need to create VLANs. We must create 2 VLANs, VLAN 10 and VLAN 20. Then enter the corresponding interface, interface J001, and configure the port link. Port trunk allows VLANs 20, and the same applies to our second interface. Interface J002, port on, link, type. Trunk, port trunk allows VLANs 10 and 20. After that, let's check if PC1 can access PC3. Now with an additional device, I can still access it, but only within the same VLAN. If I want different VLANs to communicate with each other, relying solely on VLANs won't suffice. Generally, if we want different VLANs to communicate at layer 2, meaning within the same subnet, during this process, we must utilize the MAC and IP values will definitely be blocked by the VLAN. In this process, PC, we can allow it to communicate through layer 3. This means that I can let different subnets communicate via a gateway, thus solving the limitation imposed by VLANs. Alright, now in this context, for example, 192.168. 1.1 is set as the gateway, and since we are on different VLANs, we cannot be on the same subnet. For instance, if it's on VLAN 20, I would set it to 2.11, and this side to 2.13. Here, I would also change its corresponding subnet, for example 211, and 2.1, which is its gateway. Alright, now during this process, we apply it. After applying our future gateway actually refers to an address on our device. Most of our layer 3 switches do not support converting their interfaces into layer 3 interfaces for configuration, such as assigning an IP address. Here, we need to access a virtual layer 3 interface, which means it's a fake one. You won't find an interface called VLAN interface on the device. For example, if I have VLAN interface 10, then it serves VLAN 10. If it's VLAN interface 20, it serves VLAN 20. Now, let's assign it an IP address. 192 points, 168 points, 1 point, 24 bits, and then after configuring it here, our microsingle 20 also needs to have its own gateway. Because communication is mutual, I send to it, and in the future, it will need to reply to me. When it replies to me, it also needs to find its own gateway. So here, the IP address is 192.168.2.12, 14 bits. Now, in this process, we need to pay attention to the spelling of words. If you can't remember, you can use a table which can achieve its own completion call. Now, here, we all have the gateway. After that, at this point, I use PC1 to ping 2.11. Can I communicate with it in a different VLAN? At this time, it is possible. So what does the entire process look like? Here, after sending a piece of data, the tag is applied, and the tag is retained as it passes through this interface. As it passes through this interface, the tag is retained. Once inside the switch, it will find that it needs to reach 2.0. At this point, it will check its routing table. How does it check? Here, it will display the IP routing table to check its own routing table and find that it has 2.0. At this point, it will strip off the tag of 10 internally and discover that its outgoing interface is, our VLAN ID is 20. So internally, it applies the tag of 20 before exiting. Since we are using a trunk, the tag is retained. When sending, we access and remove the tag of 20, so both parties can communicate. And during this process, communication is achieved through VLAN interfaces to enable inter-VLAN communication. Does VLAN still have significance? Yes, it does, because here we are only dealing with unicast communication. Unicast communication means one-to-one, where I specifically reach out to it. As for sending broadcasts, it will not do so. It will not send broadcast packets because we are not in the same broadcast domain. We are in one broadcast domain, and they are in another broadcast domain. We can only send broadcast packets to the same VLAN. As for other VLANs, my broadcast packets cannot be sent over. So this ensures both security and communication. In general, in enterprises, we usually choose to configure this VLAN interface. This is our VLAN. If anyone wants to learn Huawei's technical terms or wants to obtain Huawei certification question banks, please send me a private message. I can also engage in technical exchanges by leaving more comments below the video.